when we run EIGRP. Actually only one. We run EIGRP on a 224.0.0.10. All devices go to monitor point 10. But we run OSPF today differently. They will be different roles listening to different channels. All future DR other updates will be sent to point 6. DR and BDR to monitor point 6. Now the yellow line is listening. The green line is sending. DR and BDR to monitor. That is, all information sent by DR other. Sent to this multicast channel. DR and BDR go to see the data in this channel. You can imagine this channel as DR other reports to DR. DR other sent an update. DR and BDR received. After receiving, DR will tell this information to other devices. That is R3. Notify this DR other. DR sends the information to the multicast address point 5. I'm not saying send it directly. Then all other routers. Please pay attention. I'm talking about all routers. All other routers will listen to this point 5. That is, now DR sends the data to point 5 here. Then R3 goes to monitor this. 5. Then it has received the update issued by the DR just now. This is just when DR other is doing an update. If DR will issue an update in the future. For example, DR has an extra network segment. 3.3.3.3. It will send the information directly to the point 5. It is not issued 4.6. Because all devices will listen 4.5. Including BDR will also monitor point 5. Then if BDR sends an update, it will be sent first to all DR other via point 5. Then it is sent to DR through point 6. OSPF is like this. Its message interaction is very troublesome. So it doesn't matter if you can't remember this thing at this stage. Anyway, when you reach the NP stage, you still have to remember. Now just to give you a feel. We said earlier that we chose a DR. I chose a BDR. This means that the device will be updated in the future. Just tell DR and BDR. In the future, the DR will tell other devices. The equipment does not need to be sent all the time. Notice. Between them is DR other. There will be no database synchronization between them. All information is managed by DR. Their overall synchronization process now. You will find BDR seems to have no effect in the whole process. Because it is an alternative. If DR is gone, BDR will take over. So it doesn't actually have any real effect. When DR is gone, BDR will become DR. And then throughout the environment, we'll re-elect a BDR. So it's actually an option. And DR and BDR have some principle of election. Let me tell you first. DR and BDR do not allow preemption. Preemption means, now there are DR and BDR in the environment. If both devices are functioning properly, is it not due to joining a device? Its parameters are better than these two. It can become DR. It won't. Because as a DR, it must be important. Core nodes in our network. It cannot be easily changed. In order to ensure the overall stability, it is not allowed to change easily. So how are DR and BDR elected? So many parameters. What are the parameters of the election? All parameters are bigger and better. The first is interface priority. I just said. In fact, the declaration of OSPF is based on the interface. So is the interface priority. In fact, the role of the interface is DR or BDR. The default interface priority is 1. Then the range is 1-255. This is one of its rules. The second is the router ID of our device. The bigger the router ID, the better. Here are the two comparison parameters. Bigger is better. We will adjust the configuration later. So for the current network, if you don't want one device to be DR and BDR, do you know why there is such a demand? For example, you are now networking according to these 4 devices. This device is terrible. You don't want it to be a DR, because DR must be a device with better performance. You can manually set its priority to 0. That means it abstained from the election. It is absolutely impossible to become DR in the future. That's what I mean. If you want a device to be DR forever, you can change its priority to 255. Then it will always be DR. Then for DR and BDR, its role is to ensure that under a broadcast domain, reduce the flapping of those LSAs. Just reduce some useless flapping. For a device, it doesn't want so many duplicate updates. I saw some students asking, what scenarios are routers connected to switches used for? As a business. For example, now it is layer 2 switching. Layer 3 switching. We may configure VLAN here. Configure gateway. Further up is the exit. I really don't talk much about this kind of network architecture. That is, in actual work. This is not often seen. Actually, I'm telling the truth. At work you will rarely see so many routers must be configured in the same network segment. You will know later. The most common thing in work is actually this. OSPF is built like this. Point to point to point to point to point. It's all like this. But when we study, usually learn like this. But you will learn NP in the future. I will tell you about the scene. OSPF inner line network. In fact, I see more connections like this. Precisely because of this. We can also manually change its interface to point to point. Let it not choose DR and BDR. Save some time. Here are some optimizations you will use in the future. In fact, in the network, point to point is the most common way to see. We'll start configuring. What we just talked about are actually some divisions. There's still a little knowledge left. Let's briefly talk about the network types supported by OSPF. OSPF is based on link. This is the interface type, including link type for support. OSPF used by different transmission media. Supported environments are different. Now we are all network cables and fiber optics. The default is the broadcast type. As long as it is a network cable, the transmission medium of optical fiber is a broadcast type. If it is a serial port, WAN technology, this is point to point. This NBMA is called non-broadcast multiple access. Just like the old ATM. The frame relay environment is no longer seen. Then there is another one called P2MP below. P2P is called point-to-point. P2MP point-to-multipoint. You will learn something in the IE stage in the future, called DMVPN. But there are not many other application scenarios. Let's make a simple understanding. We are actually talking about it now. But we actually focus on the two of them. The most important thing is that this type. Because the wire network is Ethernet. Okay. Let's go on. DR and BDR. In this environment, select it as DR. Choose it as BDR.